Hello everyone, welcome to Calculus BC, lesson number 21. This is where we're going to talk about all of our theorems. We've actually already talked about IVT, the intermediate value theorem. So in this video, we're going to focus more on the other theorems. This particular video, we're going to talk about Rolle's theorem, and we're going to talk about the mean value theorem. And then we'll get to the average value theorem a little bit later. So let's go ahead and focus on what Rolle's theorem says and what the mean value theorem says, and then do a couple of examples just to show you what you need to do. So Rolle's theorem. I want to just say very quickly, if you guys look at both Rolle's theorem and mean value theorem, that there are criteria that need to be met in order for us to even apply the theorems. If any of these criteria are not met, then you can't apply them. So the first thing that I want you guys to see is that for the criteria for Rolle's theorem, f is continuous on the closed interval from a to b, and the mean value theorem, they're the first two criteria, right? So they're both continuous on the closed interval from a to b. I also want to say really quickly that C for continuous and C for closed. All right, so they go hand in hand. The next part it's going to ask here is that f is differentiable on the open interval. All right, so it doesn't have to be differentiable on the actual endpoints, but it has to be differentiable throughout the curve, and that's true for both the Rolle's theorem and for mean value theorem. So that's actually pretty awesome that two of the criteria for both of these are the exact same thing. So what is actually Rolle's theorem? So let's talk about what Rolle's theorem says. So there is one more criteria that has to be made in order for Rolle's theorem to apply, and that must be that f of a must be equal to f of b. All right, so that's one of the things. So our endpoint for a, so whatever the y value is for a, whatever our y value is for b, they have to be equal to each other. So f of a and f of b must be the same thing, right? So they basically lie on a horizontal line. So if these are all true, then what we can now do is we can actually apply these problems and say, okay, well, if I go and draw a continuous function from a to b, so continuous means that I can't have a hole, I can't have a jump in my function, and I can't have an asymptote in my function. So any of those things right here. So I go ahead and just draw just like a little hump, something like this. So if I look at this example right here, what Rolle's theorem is saying to me is this. There has to be some value c on the interval from a to b that the derivative of that value of c is equal to 0. And that's exactly what you see here. So let's draw another picture just to make sure that we're good with this. And so we're going to go ahead and do a again and b here. We'll do a little point, this and this. And again, it could be continuous and also differentiable. So we can't draw a corner, right? We can't do something in the corner. We can't have a vertical tangent. So we can draw something like this. Something like this. And you guys can see in this particular example, I have three places. But Rolle's theorem is just guaranteeing at least one place, at least some value of c. There can be an infinite amount. Students who are like, what if we just draw straight across? All right, what if we draw straight across? Well, now every value on this curve, the derivative is equal to 0 because we just created ourselves a horizontal line. So that's an infinite amount of points there. So the whole point of Rolle's theorem really is just to make sure that the derivative is equal to 0, some value of c, again, if f of a must be equal to f of b. So we have to make sure that it's continuous, differentiable, and that f of a is equal to f of b. So that's what Rolle's theorem says. The mean value theorem, again, function's got to be continuous on the closed interval. The function has to be differentiable on the open interval. And then what we really have to say for this particular example is that the instantaneous rate of change, so the instantaneous rate of change of some value of c must be equal to the average rate of change over some interval. And so the analogy that I use in class is this. Okay, so analogy in class. So we live really close to DC, and so the intersection, we're on I-66 going towards DC. And let's say that we start at mile marker 53, that's where our school is, and I live on mile marker 66. On 66, I live on. So we have a 13-mile stretch right here, 13-mile stretch. So let's say every mile we look at the speedometer and we start labeling what our speed is. And so every single mile, so 54, 55, 56, 57, we look at our miles. And let's say we average our speeds. And so our average rate of change is going to be equal to, let's say, 67 miles per hour. Which I know is not the greatest example because the speed limit on this road is 55, but no one ever does that, right? So 67 miles per hour. Well, what the mean value theorem says, and again, this is a continuous function, like we're continuously driving on this road from mile marker 53 to mile marker 66. And so our average speed was 67 miles per hour. Well, what the mean value theorem says is there's got to be some time c, or some mileage c, where we had to go exactly 67 miles per hour. In order for us to average this number, then there had to be some mileage, some place on this road that we were going exactly 67 miles per hour. And so that's really all the mean value theorem says in context to the real world. So let's go ahead and show you a couple of examples in this video, and we'll do more in the next video, but just a really good way of just showing you guys how to do these particular problems. So for example number 2, it says illustrate that the mean value theorem, illustrate the mean value theorem using the function 5 minus 4 over x, and then the interval from 1 to 4. So I'm going to go ahead over here and write that my function f of x is equal to, and I'm going to write it out as 5 minus 4x to the negative 1, and I'm looking on the interval from 1 to 4. Now the first thing we have to do is make sure that the conditions apply to us to actually use the theorem. So the first thing we have to ask ourselves is the function continuous? Is f of x continuous on the interval from 1 to 4, including the endpoints 1 and 4? Well, you guys know that the only value for x, or the only thing that's not in the domain of this function, is x equals 0. So if 0 was in the interval, mean value theorem would not apply. But it is continuous. It is continuous on the interval of 1 to 4. Well, the next thing we have to know is the function differentiable on all intervals. Oops, sorry. Well, we already know it's going to say yes to that, but is it differentiable on the interval from 1 to 4? So if we really quickly, and we'll have to take derivative anyway, so we're just kind of getting a head start here with this. So mean value theorem, you will always take a derivative because, again, we want to find the instantaneous rate of change. But the derivative of 5 is 0, and the derivative of negative 4x to negative 1 is going to be 4 over x squared. Right? I just used the power rule, move the negative 1 down, multiply by negative 4 to the 1 less power, rewrite it like this. So again, on the interval from 1 to 4, is this differentiable on the interval from 1 to 4? And the answer is yes. Again, the only place that f of x is not differentiable is, again, at x equals 0. So we know it's differentiable. So now that we're able to answer yes to both these questions, then yes, I can now apply the mean value theorem. So what do we have to do to apply the mean value theorem? Well, the first thing is we want to find what the average rate of change is. So, and this is the easiest part, I think. So we want to find the average rate of change. So we want to go ahead and find what f of 4 minus f of 1 all over 4 minus 1 is. All right, so that's the first thing we want to do, is find the average rate of change. And again, you're going to be given an interval because you got to figure out if it's continuous and differentiable on that particular interval. So if I plug in 4, right, so over here, f of 4 is going to be equal to 5 minus, well, 4 over 4 is just 1. So 4. So f of 4 is going to be equal to 4. And then f of 1 is going to be equal to 5 minus 4 divided by 1 is 4 is equal to 1. So f of 4 is 4. F of 1 is 1 over 4 minus 1. So I get that the average rate of change is going to be equal to 1. All right. The average rate of change is equal to 1. So remember, I want to set the average rate of change equal to the instantaneous rate of change. But in order to apply the mean value theorem, I need to figure out what value c does this equal 1. So I want to say, okay, well, f prime of c is going to be equal to 4 over c squared. So I just went ahead and found the instantaneous rate of change at some value c. And the whole point of mean value theorem is to figure out what is the c value. Well, this is pretty easy to do, ladies and gentlemen, because we're going to go ahead and set it equal to 1. Right? So this is where we're at the instantaneous rate of change at time equals c, and this is going to be the average rate of change. And that's all that you do. That's all you do. And so we're just going to simply solve for c. And so we're going to cross multiply. We're going to get 4 equals c squared. And we're going to get c is equal to positive and negative 2. But we have to look at the actual interval itself. The interval is from 1 to 4. So the answer here is going to be 2. So at time equals 2, we can now say the mean value theorem applies. So time equals 2, the average rate of change is equal to the instantaneous rate of change, and they're both equal to 1. Okay, they're both equal to 1. So that's the idea behind the question. And so again, I hope that makes sense. That's a pretty straightforward problem for the mean value theorem. And then over here it says determine whether Rolle's theorem applies to this function over the interval from 0 to 6. So if you guys look at this problem, it's got 3 minus the absolute value of x minus 3. And so the first thing we want to do is it continuous? Is it continuous over the interval from 0 to 6? And yes, it's differentiable everywhere. I'm sorry, it is continuous. It's not differentiable everywhere. It's continuous everywhere, right? Just an absolute value function where, yes, so it's yes. Now the question is it differentiable on the interval from 0 to 6? Well, what happens when we look at x equals 3? We know that at x equals 3, this becomes 0. This absolute value comes 0. So we know that the graph, without doing a crazy sketch, we know that it's going to look something like this, right? Something like this. So we know that x equals 3, it's not differentiable, right? Because there's a sharp corner here. So this is not differentiable. So for this particular example, ladies and gentlemen, we can say with all certainty that Rolle's theorem does not apply because f of x is not differentiable on the closed interval from 0. Oh, sorry, on the open interval. On the open interval from 0 to 6. And more specifically, not differentiable at x equals 3. And we were going to do an example in the next video where Rolle's theorem will apply, and then I'll show you guys how to do it. So just sit tight, we will do that question. But right now, that is just the introduction to the mean value theorem and Rolle's theorem. And so come back to us in the next video where we do more videos for the mean value theorem and Rolle's theorem. So I'll see you guys in the next video.